Hello, good morning. This is Farhan from the Republic 2.0, and today's topic is the first unit of Edexcel AS Level Physics, and we are going to talk about 1A topic of mechanics, and that is moments. So, first of all, what is a moment? Every one of us knows what the force is, right? Whenever you're talking about a force, force is an agency which tends to change the state of the body, whether to bring a state of motion into the state of rest or the state of rest into the state of motion. So that is what the force is. So whenever you're talking about the force, force is an, whenever you're talking about a force, force is an agency which tends to change the state of body, which tends to change the state of the body. That is what you call the force. But remember, whenever you're taking force as force, the forces tend to make the body move in a linear motion. It would be making the body rotate or a move in a linear motion. But whenever you're talking about the moment, moment is also a force, but it is the rotational analog of force. Whenever a force is going to rotate a substance or an object, the force would become a moment. So moment, whenever you're talking about the moment, moment is the rotational, moment is the rotational analog of force. It is the rotational analog of force, meaning thereby that whenever you're talking about a force and that force causes an object to rotate, like for example, when we are applying a force on a door, that door would not be moving in a linear motion. That door would be rotating around some fixed axis. So that force would not be a force anymore. That force is going to be the moment, right? So whenever you're talking about the moment, it is basically a rotational analog of force, which can be calculated by, if you're going to calculate moment, there is another word for the moment, and that is torque. And what does the torque means? How can we calculate the torque? We just need to times the force with the moment arm. We just need to times the force with the moment arm to get the torque or the moment. Moment is just another name for the torque, right? Now, the next thing is that you guys must know what the moment arm is. So whenever you're talking about the moment arm is basically the perpendicular distance. Moment arm is basically the perpendicular distance between axis of rotation and point of action of force. Okay? It is a perpendicular distance between the axis of rotation and the point of action of force. For example, if you could see, this is the axis of rotation of the door. Because, for example, let it be the handle of the door over here. So you are going to apply some force on the handle, and that door is going to rotate around this axis. So the perpendicular distance between the lock and these axes of rotation is known as the moment arm. So that is how we take the moment arm as, right? The perpendicular distance between the axis of rotation, this is an axis of rotation. The points or the line around which the door is going to rotate. And whenever you're talking about this lock is the point of action of force. This lock is a point of action of force, right? So that is how we calculate the moment, right? It is just a rotational analog of force, and the formula is simple: force and moment arm. And a important principal concept from here, remember that force would always be inversely proportional to the moment arm. If we keep the torque constant, remember that force would be inversely proportional to the moment arm. Higher the distance of the application of force from the axis of rotation, lower would there be a need for the force, right? For example, if you get back to the same door, you can open that door by applying the force at point A or at point B as well. But since at point B, the moment arm is quite small, right? The distance is quite small. So if the distance is quite small, the force that you need must be larger. Now, if you look at the distance, the moment arm is more as compared to the B. So since moment arm is more, so you would need a very little amount of force to open up the door, right? So this is the principal relationship that you must know to answer any theoretical question if it comes up in the past paper. So that was all about the moment of the force. And the next related topic to the moments is the principle of moments. Whenever you want the body to be in equilibrium, it must satisfy two conditions, right? So principle, and one of them is the principle of moment, and one of them is a principle of moment, right? Now, for example, if you're talking about the principle of moment, before talking about the principle of moment, we need to talk about when a body is said to be in equilibrium. A body is said to be in equilibrium if it satisfies two conditions. The first condition is that the summation of forces acting on an object should be equal to zero, and the summation of torques acting on an object should be equal to zero as well, right? So these are the two conditions for the equilibrium. The first one, that there should be no resultant force and there should be no resultant moment. And now, what is the principle of moment? What is the principle of moment? Principle of moment states that for a body, to be in equilibrium, clockwise torques, acting on it should be equal to anti-clockwise torques, right? So this is the principle of moment, that the clockwise torque acting on an object should be equal to the anti-clockwise torques acting on an object, right? So that is what, whenever we're talking about the principle of moment, this condition must be satisfied, that a body to be in equilibrium, the clockwise torques acting on it should be equal to the anti-clockwise torques. Okay. Now the next thing, right? We need to know what the center of gravity is and how can we calculate the center of gravity of an irregular object. That is a very important thing. So first of all, we'll be talking about the center of gravity, because center of gravity hold primary importance whenever we're doing some questions regarding the principle of moments, right? So center of gravity. Now the thing is that whenever you're talking about the center of gravity, how would you define the center of the gravity? Center of gravity is a point on an object, such a point on an object, where the total weight of substance acts downwards. So this is how we talk about the center of gravity, such a point on an object where the total weight of substance acts downwards, right? That could be the center of gravity. Now, for example, if we're talking about the center of gravity of you know, of regular shapes, for example, we've got a rectangle like that. So if somebody's asking me to calculate the center of gravity of this rectangle, what I'm going to do, I'm just going to draw their diagonals, for example, like that. This is the first diagonal, and the other diagonal going to be something like that. Now you can see that both of these diagonals are intersecting at a simple point, and that point over here is known as the center of gravity. So whenever you want to calculate the center of gravity of a regular object, it's very simple. You just need to draw their diagonals, make them intersect at a common point, and that point is going to be the center of gravity. But the thing is, how would you calculate, or how would you find out the center of gravity of an irregular shaped object? Now, irregular shaped object could be anything that is undefined, right? How would you calculate the center of gravity, or how would you find out the center of gravity of irregular shaped objects? That is the main question now. How would you find out the center of gravity of irregular shaped objects? Now, the thing is that whenever you're talking about the irregular shaped objects, right? For example, if you've got a shape like a cellular amoeba, or any sort of shape, right? I'm just drawing this shape. You could do any other shape as well. For example, we have got a shape like that, right? And we need to find out their center of gravity. So what I'm going to do, I'm going to plug in three holes at different spots randomly. So these are the three holes in that structure: A, structure B, and hole number B. And I'm going to pin them into the nail at these 3 points gradually, right? First of all, I'm going to draw a straight line from A like that. Then I'm going to draw a straight line from B downwards like that, when I'll be pinning it with the help of a nail. And then I'll be drawing a line like that as well. So you can see that whenever you're going to do that experimentally, they would be intersecting at a common point. And that common point is known as a center of gravity. So this is how we find out the center of gravity of an irregular shape objects, right? So this is what we have in the moment. And now we'll talk about a question that has been in the past paper from this topic. It is 2022, I guess. Okay, if I read this question out for you guys, a woman supports a stationary wheelbarrow by exerting an upward force P on the handles. This one, right? An upward force R from the ground acts on the wheel, right? This is upward reaction force on the wheel. The center of gravity of the wheelbarrow is marked on the diagram. So this is the center of gravity, right? Where all the weight of the wheelbarrow would be concentrated. Explained by considering moments about G, about the center of gravity, why P is less than R. So first of all, why P is less than R? Why the force applied at P should be less than the reactive force? Now, first of all, if you look at the moment arm, or the perpendicular distance between the axis of rotation and the line of action of force. So this is the distance from P, and this is the distance from R, right? So if I talk about it, you guys can easily see that since the moment arm, since the moment arm of P is larger than that of R, since the moment arm of P is larger than that of R, so upward force required, upward force required at P should be less than that required at R. And the reason behind it, I've been telling you this reason when we were talking about the moments, that the force is inversely proportional to the moment arm. You can see that at P, the moment arm is bigger than that of Q. So the force required at P should be less than that of R. So you just need to go with a simple relationship and you'll be done with this question. I hope that does make sense, right? So this is how we're going to attempt these questions, right? So thank you very much. That is the topic for moments. And we'll be looking forward to the next topic. Please like, share, and subscribe the lesson. Thank you very much.